In this video, we're going to talk about Chapter 10. And Chapter 10 is all about sampling. We don't have any math in this chapter. It is all vocabulary, so I'm going to just apologize ahead of time for a lot of talking. So we typically have a large population that we want to understand. And it's usually very difficult to simply gather information on an entire population. So we collect a sample, which is a subset of the population. The challenge is to find a sample that is representative of the population and without bias. And we want this because whatever statistics we gather from the sample, we want that to correspond accurately to the parameters of the population. So we want to use methods that apply randomness so that each object or person in the population is equally likely to be chosen as part of the sample. And this randomness allows us to account for all of the characteristics of the population, those that we know and those that we don't. What do I mean by that? What I mean is that when we talk about a representative population, sometimes I get questions like, well, if we know what the population looks like, then why don't we just make sure that there's at least one individual in the sample that matches each characteristic of the population? But there are times when we don't know all of the characteristics of a population, and randomness accounts for this. So it makes it so that we don't have to sit there and list out the characteristics of the population and try to match it up. We use this randomness to make sure that, one, we get all of the characteristics that we know about, as well as any characteristics that we haven't paid attention to. So we also want to recognize that in any sample, there's always going to be sampling variability. So even if we take two samples that are fabulous, they are representative, they're without bias, and we calculate statistics on those two separate samples, those statistics will probably be close, but they're not going to be exactly the same. And the statistics of those samples are also not going to exactly match the population, and this is because of sampling variability. It doesn't mean that there's anything wrong with the samples. It just means that we have this natural variability going on. And that was a big topic when we talked about simulations, that your simulation might give a slightly different final result than somebody else's simulation, even though you did them in exactly the same way and there's no actual error in anything. The other words that are used for the sampling variability, that's how I usually talk about it, but I've also heard sampling error or variation due to sampling. They all mean the same thing. So we're going to study several different sampling methods that will apply randomness in an attempt to achieve this unbiased and representative samples. And then we'll also talk about a couple of other sampling methods that are quote-unquote bad because they will every time have bias involved. In the end, though, the sampling methods that we choose in the real world will completely depend upon the population, what's being studied, and the resources that we have, the time and the money. So these quote-unquote bad sampling schemes, you actually see them a lot, and you see them a lot because they are quick and they're cheap. So we do have to take into consideration the resources that we have when we're creating samples. Okay, so first talking about the quote-unquote good sampling methods, the sampling methods that apply randomness in an attempt to get a representative sample without bias. So I'm going to go through each of these. There's 5 of them, and I'm going to describe each one and then use it in a scenario. So the scenario I have is I want to investigate the Office 365 features that are being used by HCC faculty. So HCC has Office 365 now, and I just want to study what are the features that different faculty are using with this new program. So the first thing that we can talk about, the first type of sampling method, is a census. A census just means that we sample the entire population. It sounds ideal, but honestly, it's not always ideal. A lot of times a population is very large and can be very difficult to sample everyone in the population. It also can take a long time to complete, and while you're then trying to complete this census, the population might be changing. So in my example, this would just mean that I survey every HCC faculty member using their email, right? So I just send an email to every single HCC faculty member. Now, this might actually be fine for what I'm looking at here, but also consider because we just actually finished one, the United States just finished their census for the population of this country. And there's always a lot of talk about the census for the United States because it leaves out entire groups of people and takes a really, really long time to achieve. What is probably a better way to figure out the population of this country is not to use a census, but to use some other type of sampling method. So another type of sampling method is called a simple random sample, and we abbreviate it as SRS. This is theoretically the ideal way of sampling, and I think about it as a lottery. So basically we would take the entire population, put it on a list, assign a number to each object or person in that population, and then randomly generate numbers until we get the sample size that we want. So in my scenario here, I would just use a list of the entire faculty. I would assign a number to each person, and then say I just randomly generate 50 numbers and contact those corresponding faculty members. So this is it's a very good sampling method. It uses randomness and has, it typically can have a very good representation of the population, but it can be hard to achieve if the population is very large and spread out. You can kind of say that about all of these, though. It's always hard to sample a population that's very large and spread out. Another type of sampling method that we have that uses randomness is called a systematic sample. So it's a little bit similar to a simple random sample where we still have this long list of the population and we've assigned numbers to this list. But instead of just generating random numbers, we generate a random starting point, and then we take every nth object or person after that. So in my example, I would say that I would randomly generate a starting point and then contact every 40th faculty member on the list. So this would be a systematic sample. It can have a problem if there is some kind of pattern to the list of the population that you've created, because your sampling method also has a pattern. So if those patterns somehow end up corresponding, we could have a problem. But systematic sampling is typically used in something like manufacturing. I actually worked for like an IBM manufacturing plant when I was in college, making hard disk drives that go in computers. And basically, we would take every case of disks, like every 5th case of disks, and inspect it, right? We wouldn't inspect every case. We'd inspect every 5th case. So we were using a systematic sample to look for scratches or dents or things like that on the disks. Another type of sampling method is called a cluster sample. And this is usually mixed up with a stratified sample, which is on the next page. It's the next one we're going to look at. So I'm going to talk about these two types of sampling methods a lot. So first, a cluster sample looks for naturally occurring representative groups, randomly selects one or more of the groups, and then samples every object or person in those groups. So for example, in my scenario here, the naturally occurring representative groups might be the divisions, right? There's a math division, an English division, a humanities division. So maybe I would randomly choose 3 divisions, and then I would contact every faculty member within those divisions. So this is a good choice if the population is large and spread out and simple random sampling isn't possible, but it could be a problem if the clusters are not actually representative of the population. Compare that with the next one, which is a stratified sample. So a stratified sample also does grouping, but it does grouping in a different way. It will create homogeneous groups called strata, and the homogeneous groups will have some characteristic of the population in common. And then in a stratified sampling method, we would do a simple random sampling method on each group, and we would have it proportional to that characteristic. So in my example, say I'm looking at the characteristic of the years that faculty have been with the college, with maybe the idea that the longer you're with the college, the less likely you are to want to, try another new technology. So say I'm going to divide the faculty up based on years worked at the college. So I have a group that has worked from 0 to 5 years, another group where they've worked from 6 to 10 years, and then 11 to 15 years, and so on. And then I would use a simple random sampling method on each of those groups. And I would take the number of people in that simple random sample should correspond proportionally to the percent of people within that group compared to the group as a whole. So what am I trying to say there? So like if 25% of the faculty has been with the college from 0 to 5 years, then I want to make sure that 25% of my sample came from that group. I'm hoping that makes sense. Don't focus on that. Okay, so this is really good when the strata differ from each other, but that the individuals within each group, within each stratum, tend to be alike, because then the samples within each of those groups tend to vary less. We do have a 6th version here, which is called multi-stage. I'm not a real fan of this, but your textbook uses it, so I think it might show up in your MyLab homework. But a multi-stage sample is just when they combine several different methods in a sampling scheme. But you can already kind of see that some of these will combine different methods since they're using a simple random sample while creating groups and so on. So I always think that multi-stage is a little bit confusing, but that's what they mean. Something where maybe they use a cluster sample and a systematic sample. All right, so I have a page here where I have an example and then I'm going to display the answer. So I would suggest after I read through the example to pause the video, try to think of, decide which one you think is the answer, and then hit play to see what the answer is. So the example: to estimate the unemployment rate, a government agency draws a simple random sample of households in a county. Someone visits each household and asks how many adults live in the household and how many of them are unemployed. So the question is, is this a cluster sampling method or a stratified sampling method? So I want you to think about what are the groups, how are the groups being chosen, and how are the groups being sampled, and then decide if it's a cluster or stratified. Remember that with a cluster sample, you have naturally occurring representative groups. You randomly select the groups and then survey everyone within that group. Whereas a stratified sample, you have homogeneous groups and you are randomly surveying from every group. So this is going to be a cluster sample, and that's because you have these naturally occurring groups being the households. So the households within this county are the naturally occurring groups, and they are randomly selecting these groups. And then they are going and they are surveying every single person within that household group. So the clusters are the groups of adults in each household in the county, and it's a cluster sample because they are doing a simple random sample of the cluster selected, and every individual within each cluster is a part of the sample. That's actually kind of, that end part is what I look at. When they look at the groups, are they randomly selecting individuals from the group, or are they surveying everyone within that group? If they're surveying everyone in the group, it's a cluster sample. If they are randomly selecting individuals from the group, it's a stratified sample. So there are two quote-unquote bad sampling methods, but methods that have inherent bias in them. They will always be biased. One of them is a convenience sample. So this is basically taking a sample of whoever happens to be convenient to you at the time. So in my example, I say that I'll just survey anybody that I happen to see at meetings this week and ask them to, fill out the survey. The problem with a convenience sample is it's not going to be representative of the population. You're probably going to be missing entire groups of people, right? Maybe all of my meetings this week have to do with math people, and I don't get anybody from the English or humanities division in my sample. But there are times when a convenience sample is simply the only option. So I was reading one where, say you've got a manufacturer of like big concrete blocks, right? We just did like a little wall outside in our patio, and we have these big concrete blocks, right? And they come on this huge pallet. And say a company wants to survey the concrete blocks to see if there's any cracks or dents in them, like big dents, right? Concrete always has a little bit of dents. But anyway, my point is that if you had this huge pallet of concrete blocks, you couldn't do a simple random sample and then choose one of the bricks on the bottom of the pallet. It just doesn't make any sense in a company that you would remove all these bricks just to look at a bottom brick to see if it's cracked. You would need to do a convenience sample and sample the bricks that you can have easy access to see if they have any cracks. So there are times when basically, even though a simple random sample would be ideal, it kind of doesn't make sense in a real world application, and so a convenience sample is used. However, we have to note with a convenience sample that there is an underrepresentation, and you're going to miss entire groups within that population. The other type of quote-unquote bad sampling method is voluntary response sample. And you have all seen this. Every time an app asks you to rate it, every time you go online and you go to purchase something and they want you to fill out a survey or whatever, that's a voluntary response sample. It's when a large group of individuals is invited to respond to a sample. So an example for my scenario would be if I posted on the HCC website for any faculty to respond to my survey. Basically, this has a lot of bias in it because people who have strong opinions tend to be more motivated to respond to that survey. Also, people who tend to have negative opinions, strong negative opinions, are more likely to respond than those with strong positive opinions. But it's definitely, you're missing an entire groups of people who have not strong opinions. They still have strong opinions and they matter, but we're missing those people. So I do get a lot of questions about voluntary response versus some of the good sampling methods. In that there's this idea, okay, so sorry, I'm trying to figure out really how to say this. So we all always have a choice on whether or not we want to respond to a survey, right? I can do a great, simple, random sampling method and send out my survey to 50 people and only have 10 respond. So how is that different from a voluntary response sampling method? The idea is the researcher choosing who they're sampling, or are they just putting it out there and hoping they get some people? So in the 5 methods that I described previously, the quote-unquote good methods, we're specifically setting out to see exactly who we want to sample, and then we're targeting those individuals with a survey. Whereas the convenience sample and the voluntary response sample, we're not targeting any specific individuals. We're just throwing it out there and seeing if anybody will respond. And that's the difference. The difference is in how the researcher is choosing who is being part of the sample. But in the end, everybody always has free will on whether or not they actually want to respond to a survey. Okay, so on this page, I've got 4 examples where I want you to identify the sampling method. So again, I'm going to talk through the example, and then if you want to pause it, decide what type of sampling method it is, and then play again to see the answer. So on this example, it says Major League Baseball tests players to see whether they are using performance-enhancing drugs. Officials select a team at random, and a drug testing crew shows up unannounced to test all 40 players on the team. Each testing day can be considered a study of drug use in Major League Baseball. What kind of sample is this? This would be a cluster sampling method. Because the teams are the naturally occurring representative groups, they're randomly selecting a team. So they're randomly selecting a group and then testing everyone on that team, testing everyone within the group. The next example. Dairy inspectors categorize farms by their size. They visit randomly chosen farms from each size category and take random samples of milk to test for contamination. If the milk is found to contain dirt, antibiotics, or other foreign matter, the milk will be destroyed and the farm re-inspected until purity is restored. What kind of sample is this? So this would be a stratified sampling method. And this is because the groups, the homogeneous groups, are that the farms are grouped by their size. And then every group is surveyed, but the farms are chosen at random within each group. The next example. An amusement park has opened a new roller coaster. It is so popular that people are waiting up to 3 hours for a 2-minute ride. Concerned about how patrons feel about this, they survey every 8th person in line for the roller coaster, starting from a randomly selected individual. What kind of sample is this? This is a systematic sampling method, and we know that because of this every 8th person piece. We also have a randomly selected starting place. All right, last example. A recent radio station asked listeners to go to their website and vote for their favorite singing star. A respondent would be randomly chosen to win 2 tickets to the performance of their choice. What kind of sample is this? This is that voluntary response sampling. The radio station isn't targeting certain individuals. They're not choosing their sample. They are just throwing out the survey and trying to entice people to come in and fill it out. All right, so samples that over or under emphasize characteristics of the population are said to be biased. And we want to have samples that don't have any bias. Now, if you were to look up types of bias, you would see a huge amount of types of bias. We're going to specifically talk about 4 that have to do with sampling. The big thing with bias is that once it's part of your sample, there's no way to get rid of it. You can't discover halfway through your sampling that you have bias and then somehow change it so that you can get rid of the bias. Once it's there, it's always there. And then ultimately, conclusions based on samples that have bias methods are flawed, and you really can't make any good conclusions from them. So the first one is voluntary response bias, and obviously this would be a result of a voluntary response sample. So the bias is that basically people with strong opinions or strong motivations, like in the previous example where they could win tickets, tend to respond. Another type of bias is undercoverage, meaning that an entire subset of the population is either way underrepresented or is left out completely. And this usually results from a convenience sample or anything where we have an incomplete sampling frame. This is also kind of what I was talking about with the United States taking the census, where entire groups are left out of that census, specifically homeless people or undocumented immigrants are left out of the United States Census. So even though it's a quote-unquote good sampling method, there's still bias in it, and in that case there's undercoverage. Response bias is when anything about the survey influence responses. So it could be, for example, say a teacher wants to do a survey of her statistics class. So she writes out the survey, hands it out to her students, and then walks around the class while the students are filling out the survey. Right? This is a response bias. Having the person in the room that you're supposed to be writing the survey on is intimidating, and people might not give their full thoughts or feelings if the person is standing there. You could think about the wording of a question. If the wording of a question tries to steer a person towards a certain response, then that's also a response bias. You also want to keep in mind that people don't usually want to talk about their personal facts or flaws or any illegal behavior that they've done, so there might be a response bias there. A non-response bias means that a large number of people don't respond. So, this can show up in basically any type of sampling method, because remember I said we all have a choice on whether or not we want to fill out a survey, right? So I could design this fabulous sampling method with a simple random sample where I send it out to 200 people and I only get 20 surveys back. Well, I can't really make any conclusions when I have that large of a non-response bias. I had so few people respond to the survey that that's what it is. So basically, the non-response bias, we're kind of saying so many people didn't respond to the survey that we really don't know what those non-respondents would have said. All right, so a few other just vocabulary words to know before I do another couple of examples. So first, the word sampling frame. Usually I make these purple. I guess I forgot to do that with this one. So a sampling frame is the list of individuals from which the sample is drawn. Now, you heard me kind of say that when I was talking about my example with the HCC faculty, that I could make a list of all of the faculty, and then I could do a simple random sample from that list. Well, that list of the faculty would be my sampling frame. The question is the sampling frame always the same as the population? And the answer to that is no. And so I would hope your next question would be, well, why wouldn't it be? So sometimes we know what the population is, but we don't necessarily know all the people within the population, or we can't actually contact all the people within the population. So, for example, say, we just had a presidential election. So say there was a polling agency and they want to do a poll on who you're going to vote for, right? They're trying to predict which candidate is going to win. So ideally, their population is people who are going to vote. Well, how do you identify the people who are going to vote? Do you look at registered voters? I mean, you could be somebody who's registered to vote, but who doesn't vote. There's also same-day voting. So even if you're not registered to vote 2 weeks before the election, in some states, you can register the same day and vote. So that idea of just registered voters isn't the population, right? The population, again, is who will vote. So how do you define your sampling frame? Do you make it all adults? Do you make it only adults who are registered to vote? That's a really big question, and that's part of the reason why polling for presidential elections is so difficult. The other thing that I see a lot when I'm grading homework or looking at problems is that students will get the question, what is the parameter of interest? They get this wrong a lot. So what does parameter of interest mean? So in Chapter 5, we talked about the difference between statistics and parameters. But here's kind of what happens. We have this large population. We take a sample of that population, and then from the sample, we calculate statistics of that sample. And the statistics are the mean of that sample, the standard deviation, or the proportion. And then from those statistics, we want to make inferences about the population measurements of the mean and the standard deviation and the proportion. Those population measurements are called the parameters. So when we say, what is the parameter of interest, we're saying, what is the measurement that we're trying to make an inference about with this sample? And keep in mind that measurements are things like the mean, the standard deviation, the proportion, the median, something like that. All right, let's do an example. Again, you can pause to try to think of the answer before looking at the answer. So administrators want to understand how currently enrolled students are placing into their current math class. They randomly choose 5 math courses and ask the instructors to post a survey on their Canvas site for students to complete within the first week of class. The administrators will calculate the proportion of students that placed into their current math class by their high school GPA. This is actually a survey that we're actually doing, and I posted this survey to your Canvas cite within the first week of class. So I'm kind of using a real world example here. So the first question is, what is the population of interest? What is the population that these administrators are trying to understand? The population is currently enrolled students. Administrators want to understand how currently enrolled students are placing into their math class. What is the population parameter of interest? So remember that a parameter is a measurement. What is the measurement that these administrators are looking to make an inference about? Well, there's only one measurement listed in this entire paragraph, and that's proportion of students. The proportion of students that placed into their math class by their high school GPA. So that's the population parameter of interest. What is the sampling frame? This one's tricky, and a lot of people get this wrong. What is the list that these administrators are using to then sample the individuals? The incorrect answer is the 5 math courses. That's what a lot of people say, but that's not correct. The correct answer is currently enrolled students taking math. So the administrators want to understand how all currently enrolled students are placed into their math class. But a lot of people who start off at HCC don't necessarily take a math course in their very first semester, right? They're not in a math course every semester that they're there. But the only access that these administrators in the math division have are to math students. So their sampling frame is currently enrolled students taking math. And from those currently enrolled students, they have naturally occurring groups, representative groups, meaning naturally occurring classes. They're randomly choosing 5 of those groups and then surveying everyone within that group. So when it says what type of sampling method is used for this study, that's going to be a cluster sampling. And again, I do sometimes have people say, well, this is a voluntary response sample because you're just posting it to the Canvas site and asking people to respond. But remember that the difference here is that the researchers, the administrators have picked out who they're targeting, specifically who they want to fill out this survey. And then they're offering you the survey. Now, not all of you filled it out because you have free will and you don't have to fill out a survey if you really don't want to. But that doesn't make it a voluntary response sample. A voluntary response sample would just be if the administrators just put it on the HCC website and asked anybody to fill it out, right? They're not trying in any way to target certain individuals. But in this example, they are targeting certain individuals. Who was possibly left out of this study? So think about the difference between the population of interest and the sampling frame. The people who are left out are people who are not currently taking a math course. There's also people who, not everybody might know this, but there's also people who might sign up late. We have late start courses. And so they aren't in a math class in the first week of classes, or in the first week of the semester, but their class starts 3 weeks in. So that would be 2 options for people who might be left out of this study. And then I have one more example down here, just to look at the difference between a statistic and a parameter. So I have 2 statements, and you want to decide which statement represents a statistic and which statement represents a parameter. So if I say 57% of teachers are female, Is this a statistic or a parameter? This is a parameter because it's describing an entire population of teachers. Whereas if I say, in a sample of 100 surgery patients who were given a new pain reliever, 78% of them reported significant pain relief. Now I'm specifically talking about a measurement that was taken from a sample. This is a statistic. So a parameter is a measurement about the population. A statistic is a measurement about a sample. All right, just one more quick thing. And I know it's at the end, but that doesn't mean it's not important. One other quick idea that I want to throw out there is that when we're talking about taking a sample, when we talk about what size of sample we take, a lot of times there's a misconception that the larger the population that you have, the larger your sample needs to be. But that's not actually the case. You could have a sample size of 100, and if it's representative and unbiased, that sample could be from a population of, say, 10,000 students or 300 million voters. If it's representative and unbiased, it's a good sample. I don't want to somehow say that it's not important to have a large sample size. It is. It's important to have a large sample size. But if you do a voluntary response sample and you get 12,000 people to reply to this survey that you threw out on the internet, it doesn't really matter because there's so much bias in that survey. It doesn't matter that it was super big. What's more important for the survey is that it be representative and unbiased. One other final note is that, researchers will always report their sampling method in great detail. And if you ever want to see this, there's some great websites out there. My favorites are I really like this one, 538.com. They have a whole bunch of statistics stuff. But you can always kind of go in and look, if you follow some links, they'll describe in a lot of detail, like pages of detail where they describe how they take a sample. Another good website that's got a lot, examples of samples and sampling methods and how they describe those sampling methods are Pew Research. I think it's just pewresearch.com. I know I have a space there, but there'd be no space obviously in the link. Okay, if you have any questions on chapter 10, let me know.